Sure, we'll continue. So in case of a concave lens, okay, it will diverge more violently or it will go to more places. This is the parallel beam of light which is coming. Okay, this will go here, this will go here, this will go here. So it will diverge more than the earlier parts. And all this point should ideally meet at a common point, and that common point will be the focus. But this focus is not real, right? This is what we are assuming that it should be present at that point. So that is why we say that concave lens does not have a focus, whereas convex lens has a focus. Similarly, if a parallel beam of light incident obliquely on a concave beam lens, after the refraction, it appears to diverge from a point B in the second focal plane as shown in the figure. The focal length of a lens depends on the following two factors. Two factors are responsible for the focal length. First, the refractive index. Okay, what is the material, what is the lens made up of, whether it is glass or quartz or any other such kind of material. The refractive index of the material of the lens is relative to its surrounding medium. If a lens is placed in water instead of air, its focal length increases. If the medium is denser, the focal length will be more. Okay, because air के बदले अगर पानी रखा as medium, okay, so the medium is denser now, which means the focal length will be increased. Okay. Second point, the radii of curvature of the two surfaces of the lens. This is the most important point. Depending upon what is the radius of curvature, if the radius of curvature is smaller, accordingly the focal length will be smaller. If the radius of curvature is bigger, focal length will also be bigger. A lens thick has less focal length than a thin lens of the same material. If a lens is thick, which means, for example, this is lens, this is thick lens, right? Let me draw a bit smaller lens. This is made from this circle and this is made from this circle, right? So this will be the radius. Imagine now this, it is a thin lens. This is made from this circle, which is not even coming here, right? Which means thinner the lens, more will be the radius and more will be the focus. The radii of curvature of two surfaces of the lens. A thick lens has a less focal length and a thin lens of the same material. If a part of lens is covered, its focal length remains unchanged. If a part is covered, so if I per se use only this part of the lens, the upper part of the lens, and the lower part is all covered, still the focal length will not change. Okay, because the radius is not changing, so focal length will also not change. Only the amount of light entering the lens decreases, due to which the intensity of an image decreases, but the position, size, and the nature of the image formed by it do not change. All the things will remain the same. Okay, nothing will change, not the nature, nor the position, nor the size. Just the amount of light, just the intensity or the brightness of the image will change. One of the most important questions from this part is difference between convex and concave. Convex, it is thick in the middle and thin at the periphery. So वो fish shape का lens होगा. Okay, convex lens. Then you have concave lens like that of a spoon. Okay, two spoons ऐसे रखेंगे तो convex, two spoons को ऐसे रखेंगे तो concave. In concave lens, the middle is thin part and the thicker parts are at periphery. Convex lens, it converges the incident ray towards the principal axis, and concave lens, it diverges the incident ray away from the principal axis. C, it has real focus, and concave lens has virtual focus. These are the major key points which you need to remember. Then you have refraction of light through the equiconvex lens and equiconcave lens. Figure 5.14 shows refraction of a light at two surfaces. Can you please resend me this one page because it is very blurred? Just click a snap and send me this image. Na? I can't see it properly. Yeah, thank you. Refraction of light through an equiconcave lens and equiconvex lens. Figure 5.14 shows refraction of ray of light at two surfaces of an equiconvex and equiconcave lens. When ray AB is incident on the lens, it suffers refraction at two surfaces, first at surface 1 and surface C. This is surface 1, this is surface 2. Okay, let's take black color. This is ray AB. Firstly, this is rarer medium, this is denser medium. Rarer medium से denser medium में जाएगा. It will move towards normal. Yes or no? Now, it is moving from denser medium to rarer medium. It will move slightly away from normal. This will be the refraction, right? If I draw normals here, say example normal LM and normal NO. Let's not use O because O is used for optical center. P, NP. Clear? This is air and this is also air. बीच में glass है. Light यहाँ पर पहले refract करेगा, then यहाँ पर फिर से refract करेगा. There will be two refractions. Refraction at surface 1 and refraction at surface 2. So ideally जो light straight जाना चाहिए था without refraction, it now goes this way. There is this bending and this bending is nothing but refraction. First, the light ray AB suffers refraction at the surface 1 from air to glass, so it bends towards the normal N1B. So they have used normal के लिए N1 and N2. हम लिखेंगे NP towards normal NP. The refracted ray BC falls on the surface 2. अब ये वाला ray of light जो है वो surface 2 पे गिरेगा यहाँ पर. Okay, so this will move away from normal. Normal के तरफ नहीं, दूर जाएगा normal से. Okay, so here the refracted ray BC then falls on the surface 2, where it now suffers refraction from glass to air, so it bends away from the normal N2C at point C and emerges out at CD. और वो CD बन के बाहर निकलेगा. So let's do the naming here. This is A, this is B, this is point C, and this is point D. AB initial, BC refracted, CD emergent. Clear? Thus, the ray of light bends at both the surfaces of the lens in the same direction, and hence the total deviation produced by the lens is the sum of deviations of the two surfaces. तो यहाँ total deviation होगा ये वाला deviation plus ये वाला deviation. That is nothing but delta is equal to delta 1 plus delta 2. This we have done in the case of prism, right? Delta, again green color is also not visible. Delta is equal to delta 1 plus delta 2, right? That was a formula for deviation. It is clear from the figure 5.14 that a convex lens bends the ray of light towards its middle. It converges the light, while a concave lens bends the ray of light towards the edges, that is from its middle, that it diverges the lens. So अगर इसका एग्जांपल देखें कॉन्केव लेंस का, यहाँ पर पहला रिफ्रैक्शन हुआ, देन यहाँ पर दूसरा रिफ्रैक्शन हुआ. रे ऑफ लाइट bends this way, then this way. Okay, so this ray of light will diverge more, whereas this ray of light will converge more. Easy? Any doubts, Vasant?
No, sir.
For ray diagram, we shall consider a lens to be thin, and for simplicity, we shall not show the bending of ray of light at each of the two surfaces of the lens separately, but we shall know the net bending of the lens by drawing a straight vertical line passing through the optical center. So we don't show this every time because दोनों तरफ refraction दिखाएंगे, so it will take much more of a time and it will increase the confusion. So we just draw a single line, but we should know that कि दो बार refraction हो रहा है. Clear? That was the last part of your chapter, right?
Yes, sir.
After this light part is done, we'll move to chemistry.
Yes, sir.
Spectrum. What do you mean by spectrum? क्या होता है spectrum? Tell me. You've heard of it, right? Spectrum. What is spectrum? Spectrum is the constituent. You can say the constituent of light is a spectrum. So white light, when it passes through a prism, we see a spectrum of light. We see the 7 colors of the rainbow. That is Vibgyor colors, and that 7 colors, this 7 combining colors together form the white light. That is spectrum. Okay, let's see the syllabus. You have using a triangular prism, produce a visible spectrum from white light, electromagnetic spectrum, scattering experiment, etc. Scattering of light, etc. So, have you seen scattering of light? Oh, summers में या in
Yes, sir.
general during the daytime when the window is open and you see all the dust particles flowing here and there and the light which is scattering, that is scattering of light. You must have also seen rainbow, the 7 colors of rainbow. That is due to total internal reflection. Okay, the every drop of water acts as a prism and then there is internal reflection beyond critical angle, and that is where you see the 7 colors getting segregated. All those things we'll study in this chapter. Basically, the chapter 6 of light is all theory. Here is where ये chapter से आपको give reason आएगा. Explain that effect, explain how rainbow is formed, explain why even after the setting of sun we can still see sun. All those things will be asked from this chapter. Clear? So chapter lengthy compared to the previous chapter, but more easy because here it is more of a theory chapter, and here you learn the application basis of it, application point of view. Let's start. Deviation produced by a triangular prism. Already we have done this in chapter 1. Okay, the chapter 1, that is the first chapter that we did together, the prism wala chapter, where we did that delta A wala thing. Figure 6.1 shows the deviation produced by a triangular prism for a light ray. When a light ray PQ of a single color enters a triangular prism ABC, it gets deviated, say by angle delta 1, towards the base BC. So here, when you draw a prism this way, and you're passing a light, say this is A, this is B, and this is C. You're passing a light, incident light, it moves towards BC. It moves away from the normal. This is normal. Okay, and here you will have one more normal. So this light ray, instead of going straight, it moves towards the normal. And at surface AC also, there will be refraction. So this ray of light will move from glass to air, that is in this direction. Okay. Here you have angle of incidence I. Here you have deviation D1. Here you have deviation D2. Okay. And where these two ray of light appear to meet, here you will have your combined delta. Clear? This angle plus this angle will give you this angle. Yes or no? Because this angle and this angle is vertically opposite angle. This angle plus this angle is equal to this angle, remote exterior triangle theorem. Sum of the two remote interior angles is equal to exterior angle of the triangle. Yes? Chalo, we'll continue forward. On striking the second surface AC, the ray QR gets further deviated, say by an angle delta 2 towards the base BC, and travels straight as RS outside the prism. The angle of deviation delta 2 outside the depends on the angle of incidence at the second surface and the refractive index of the air with respect to glass. So दो चीजों के ऊपर depend करेगा. First, the angle of incidence and the refractive index. Angle of incidence and the refractive index. Two important things on which the angle of deviation is dependent. For the emergent ray R as the total deviation delta with respect to incident ray PQ, that is the angle between emergent ray RS and PL of the incident ray PQ, delta is equal to delta 1 plus delta 2. This entire thing we have done in first chapter. Okay. वही same चीज है, delta is equal to delta 1 plus delta 2. First we draw a triangle, then due to vertically opposite triangle we equate the two angles. We have this kind of a diagram where this is delta 1 Okay, this is delta 2 and this is delta, right? This angle is equal to this angle, so I can say this is also delta 2, and sum of this angle plus this angle is equal to this angle. Easy.
Yes, sir.
The total angle of deviation delta thus depends upon the following three factors: angle of incidence, angle of the prism, and the refractive index. Here they had written two things. Now the third thing which is added is angle of prism, that is angle A. ये वाला जो angle है वो angle A. Since the refractive index depends on the color of wavelength of the light used, so the angle of deviation depends on the color of wavelength. So wavelength पे भी depend करेगा, because wavelength is nothing but color of light. Depending on the color of light, depending upon the wavelength of light, speed of light changes, and accordingly the light will bend away or it will go straight. Okay. So violet and red are the two extreme colors. That is why we say ultraviolet light and infrared light. So ultraviolet light is basically that wavelength which are greater than violet light, and infrared light are that wavelength which are less than red. In chapter 4, we have discussed light of the single color and dependence of angle of deviation delta on the angle of incidence, angle of prism, and refractive index of the material of the prism. Here we shall discuss in detail how the deviation delta is produced by a prism, depends on the color of wavelength of the incident light. Okay, the same thing which is repeated again. तीन चीजों के ऊपर डिपेंड करता है: angle of prism, angle of incidence, and mu. Let's see deviation of dependence of deviation on the color. Light of different colors have the same speed in air but different speed in a medium other than air. The light entering in a prism is not of single color. It is a mixture of several colors. Then the emergent beam too has different colors arranged in definite order. It is so because the speed of light in transparent medium decreases with the decrease in the wavelength of light. Since the refractive index of glass increases with decrease in the wavelength of light, therefore the deviation of the caused by prism also increases with the decrease in the wavelength of light. See, too much of increase decrease, too much of increase decrease is written. We'll study one by one, step by step. Light which is entering the prism is not of a single color, right? It is a mixture of different wavelengths. Yes or no? Okay. So when it refracts two times and it goes to the air again, it will bend at a certain angle because it will get separated. हर एक wavelength अलग अलग speed पे जाएगा. They are arranged in a definite order. Why this happens? Because the speed of light in a transparent medium decreases with decrease in the wavelength of light. So speed decreases if wavelength is also decreased. Clear? As the refractive index of a glass increases, so if mu is increased, which increases the wavelength as well, so the wavelength also will be increased. Therefore, the deviation caused by the prism will also be increased. So the deviation will also be increased with the decrease in wavelength. So if you decrease this, delta will be increased. In visible light, the violet color has wavelength 4000 Armstrong unit, which is deviated the most, and the red color 8000 Armstrong unit is deviated the least, because in glass the speed of violet light is least and that of red light is the most. Visible spectrum में, visible wavelengths में, violet color has 4000 Armstrong unit, It is deviated the most because wavelength come here. Less the wavelength, more the deviation. Less the wavelength, more the deviation. Deviation is inversely proportional to wavelength. Wavelength come, deviation ज़्यादा. Okay. Red color has wavelength 8000 Armstrong unit and it is deviated the least because wavelength is high, so deviation will be less. Easy. Just do one thing. Just write this thing here. यहाँ पर लिख दो so that when you revise the chapter, it becomes easier for you.
Yes, sir. Done.
Okay. Colors in white light with their wavelength and frequency. The white light emitted from a source consists of light of different wavelengths. The light of different wavelengths produce sensation of colors on the retina of our eye, so we perceive them as different colors. The prominent colors of white light are violet, indigo, blue, green, yellow, orange, and red. Different colors differ in their wavelengths. In fact, wavelength is the characteristic of color irrespective of origin. It does not depend upon the origin. Light of the same color obtained from different sources will have the same wavelength. Okay. See, this is red in color. Why is this red in color? Because light is falling on this dabba. Okay. It is absorbing all the colors, but it is reflecting red color, which means it is reflecting wavelength of 8000 Armstrong unit. And that 8000 Armstrong unit is striking on my eyes, on my retina, and that is why I can see this color as red. I am wearing white, which means this is reflecting all colors, all the entire Vibgyor color ka spectrum. This is reflecting, and that is why you can see this white T-shirt. You are wearing black, which means it is not reflecting any color. It is absorbing all the wavelength. Okay, color theory is very important because whatever color you see is not the color that actually it is made up of. It is the color which it reflects. So if a green leaf is there of a plant, the leaf is not actually green. The leaf is all the colors except green because the leaf is absorbing all the wavelength, but it is reflecting only the green wavelength, and that is what we can see. Clear? And there are obviously 7 colors, as you all know: violet, indigo, okay, blue, green, yellow, orange, red. These are the 7 colors. Usually, we are not able to see all the colors very prominently. We just see that blue shade, then we see that yellowish green shade, and then we see the orangish red shade in a rainbow, right? What are the 3 primary colors? Vasant, batao. What are the primary colors?
What, sir?
What are the primary colors?
Sir, blue, green, yellow.
Good. Blue, green, yellow, or red?
Orange, sir.
हाँ, ऑरेंज नहीं, ऑरेंज नहीं. ब्लू ग्रीन येलो है या ब्लू ग्रीन रेड है? व्हाट आर द, बताओ, प्राइमरी कलर्स क्या है?
Green, red.
Red, huh? Blue, green, and red. Okay.
Yes, sir.
Blue, green, and red, or blue, yellow, and red.
Sir, blue, green, and red.
Sure, pakka.
Yes, sir.
Chalo. There is also a disease known as color blindness where the person cannot distinguish two colors, right?
Yes, sir.
That all parts you'll study in bio. Okay. Here they have given as an extra note from the definition of refractive index. They have given mu of glass is speed of light in air upon speed of light in glass, and the speed of light of for different colors is same in the air, but it is different for different colors in glass. So the speed of violet light is minimum and the speed of red light is maximum. That is also studied here on the above paragraph. The speed of violet light is minimum and the speed of red light is maximum. Therefore, mu of violet is greater than mu of red. So if I take the sign, it is sin I upon sin r, or sin r is equal to sin I upon mu. Therefore, in glass, for a given value of I, the angle of refraction R is minimum for the light of violet color and maximum for the light of red color. ये statement important है. Please mark it down. Just mark whatever I am marking. This part. For a given value of I, angle of refraction is minimum for violet color and maximum for red color. Now angle of deviation, this part. Clear?
Yes, sir.
This can come in MCQs. In other words, the color of the subjective property of light related to its wavelength. The table below gives the range of wavelength and frequency for light of different colors present in white light. So in white light, you have your violet, indigo, blue, green, yellow, orange, red. You can see the wavelength and you can see the frequency. So 4000 to 4460 is violet, 4460 to 4640 is indigo. Then you have blue, 5 to 5780 green, 5780 to 5920 yellow, 5920 to 6200 orange, and 6200 to 8000 red. Okay. Here you will see that red has maximum range. Yes or no? 6200 से लेकर 8000 तक. The reason red light is used in major emergency services is because the range is very much. It can reach to a longer distance. The color red can be seen from a far away distance. Okay. So you must have noticed major brands, they use red color for their logo. You know Zomato ka logo is nothing but red color. The McDonald's ka logo, it is nothing but a red color ka background with a yellow color ka M. Okay, so that from far away that is visible. Ambulance uses the plus sign, that is also red in color. Okay, the red light signal, all the things which are red, which means they are more bright and they are more visible from a longer distance. In the above table, the letter Armstrong unit denotes where 1 Armstrong unit is 10 raised to minus 10 meter or 10 raised to minus 6 centimeter. Nowadays, wavelength is expressed mostly in nanometers, that is 1 into 10 raised to minus 9. See, this minus 9 and minus 10 things, they are way beyond our imagination. I'll just try to give you an analogy. Please understand it very carefully. Firstly, if I write 1 nanometer, it is 0.000001 meter. If I write 1 Armstrong unit, I'll just add one more zero here. And this value is very small, huh? Very, very small. Imagine, take a stand of your hair. If I take a stand of your hair this way, and if I cut it transversely समझते हो? So if your hair is this thick, I will cut it this way. ऐसे नहीं, not this way, in standing orientation. I'll have to cut 1 lakh pieces of your hair transversely. 1 lakh pieces, and that one piece will be of 1 nanometer. Imagine karo the thickness of your hair, cutting the hair in 1 lakh small pieces, and that one piece is 1 nanometer. If I have to make it 10 nanometer, or sorry, 1 Armstrong unit, I will have to cut it into 10 lakh pieces. Okay, so these values are very, very small. In the spectrum of white light, red color has the longest wavelength 8000 or 800 nanometers or lowest frequency. See, wavelength and frequency are inversely proportional. That also please write it down here only. यहाँ पर लिख दो ऐसे ब्रैकेट डाल के, wavelength is inversely proportional to frequency. More the wavelength, less will be the frequency. रेड का स्पीड, रेड का वेवलेंथ देखो 8000 है, फ्रीक्वेंसी कितना है 3.75. वायलेट का 4000 है, फ्रीक्वेंसी कितना है 7.5.
सर ब्रैकेट क्या लिख
ये वेवलेंथ इज इनवर्सली प्रोपोर्शनल टू फ्रीक्वेंसी.
सर डन
डन. फ्रीक्वेंसी का मतलब क्या होता है? नंबर ऑफ वाइब्रेशंस पर सेकंड, राइट?
सर
सो रेड का स्पीड ज्यादा होगा बिकॉज फ्रीक्वेंसी कम है, मतलब स्पीड ज्यादा होगा. फ्रीक्वेंसी is 3.75, so the speed will be more. Just a second. यहाँ पर देखो क्या लिखा है, the speed of violet light is minimum and the speed of red light is maximum. Yes, violet का स्पीड कम होगा, रेड का स्पीड मैक्सिमम होगा. From the violet end to the red end the spectrum, the wavelength increases while the frequency decreases. जब violet to red जाते हैं तो wavelength बढ़ेगा और frequency घटेगा. Here you can see increase in wavelength. Okay, violet to red, wavelength increases. Frequency is written as nu. Nu का symbol देखो ऐसा है. You do this way and you do this way. Nu decreases. Just write one more statement somewhere, wherever you find a place. Violet to red. Violet to red. Wavelength increases. Mu decreases. Or frequency decreases. Is this clear?
Yes, sir.
Okay. Now we'll see dispersion of light. Dispersion of white light through a prism and formation of a spectrum. Okay, this was basically done by Newton. Newton did this experiment where he took a prism and he passed white light through it. When he passed white light through a prism, he found 7 colors, or the colors got separated into its constituents, and that is what we call as vectors. See here, violet is at down, violet नीचे है ना, रेड ऊपर है. देखो वायलेट का डिविएशन सबसे ज्यादा होगा, यानी उसका स्पीड सबसे कम होगा. वायलेट का डिविएशन ज्यादा यानी वायलेट को डिस्टेंस ज्यादा ट्रेवल करना पड़ा, विच मीन्स उसका स्पीड सबसे कम है. रेड का डिविएशन सबसे कम है, यानी उसका डिस्टेंस सबसे कम होगा, उसका स्पीड सबसे ज्यादा होगा. इज दिस क्लियर?
Sir.
Okay. Sir Isaac Newton, while studying the image of heavenly body formed due to refraction of a white light by lens, found that the image is colored at its edges. He thought that colored image is due to some effect of the lens. He then repeated the experiment with a carefully polished lens, but the image was still colored. Newton then concluded that the fault is not with the lens, but there is something in the nature of white light itself, due to which the image is colored at its edges. To investigate it further, he performed another experiment with a prism. Newton's experiment, Newton allowed a white light from the sun to enter a dark room through a small aperture in a window and placed a glass prism in its path of light rays. The light rays emerging out of the prism was received on a white screen. On the screen, a colored patch of like a rainbow was shown, which is shown here also. Starting from the side of the base of the prism, the order of the colors was violet, indigo, blue, green, yellow, orange, red. The order of colors in the spectrum can easily be remembered by the word vibgyor. Okay. Conclusion from the above experiment: Newton concluded that white light is consisted of 7 prominent colors. Each color corresponds to a small range of wavelength. Thus, white light is a mixture of large number of wavelengths. It is polychromatic in nature. Poly means many, chromatic means color. So it is made up of many colors. Is this clear? Is this clear? In this spectrum, each color is mixed up with other color. That is, there is no sharp boundary line which is separating the colors. In the diagram also, colors are shown widely separated just for clarity. The total spread of colors is much less than that shown in the diagram. So spread is much less than whatever is shown. So ideally, I can just see 3 or 4 colors because our eyes are not that strong to distinguish all the 7 colors. Different colors have different width on the screen. So the width will also be the different. Width difference होगा, which means ये जो range है ना, range के ऊपर depend करेगा क्या width होगा. So red will have the maximum width. Yes or no? Because it has maximum wavelength under it. Okay, just take marking of this part. Name of the chapter firstly. Okay. Then just this angle of deviation based upon 3 factors. That's it. Okay. Should I move to the next page?
Yes, sir.
Yeah. The next page we'll write. Done.
Yes, sir.
Then next page. Yeah, that's it. Right. This also dispersion and spectrum. Dispersion is the phenomena where there is splitting of light. And the consequent colors is nothing but the spectrum. Clear?
Yes, sir.
And for that last chapter, that also 1 page marking I'll give you. Wait. That's it. Cool.
Yes, sir.
Chalo, we'll end the lecture here. Bye.